Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Today I'm going to share with you all of you, or we're going to look into the discussion and solution for topic of random variables, lecture 3 of 5, and with the subtopic of 8.3, continuous random variables. Okay, so are you all ready? Make sure that you have your lecture notes with you right now, and without wasting so much time, let's continue. Okay, so today, the learning outcomes or the objective of this, the student should be able to find the probability of probability density function in cumulative distribution function and find the probabilities from probability density function and cumulative distribution function. So now, continuous random variable are theoretical representations of continuous variables such as height, length, weight, or time. So continuous random variable x is specified by its probability density function, and this function is defined in the interval of from negative to positive infinity. Okay, so meaning that for discrete random variables, we are dealing with summation and subtraction of probabilities. And for continuous random variables, and as we call, to find the probability density function, so we are dealing with integration, and opposite of integration will be differentiation. Okay, so now, so when we talk about integral of the function fx dx from x equal to a until x equal to b, we are actually talking about an area between the curve and x-axis from x equal to a until x equal to b. So if x is a continuous random variable with a probability density function of fx, then probability of x from a until b is an integral of fx dx from x equal to a until x equal to b. So class, for continuous random variable, okay, for discrete, for example, for discrete is where we count the things one by one. We count it 1, 2, 3, 4, 5, and so on. So probability of x less than a and less than or equal to b are not equal with the probability of x greater than a and less than b, because every single things we count it one by one. But then for continuous random variables, we just measure the height, we call the distance, height, length, volume. So for for continuous random variable, no matter whether it's a greater than or equal, or less than or equal, greater than equal with less than or greater than less than equal, greater than or less than equal, or greater than and less than, we consider all of these are all the same. Okay, so then determine median from probability density function. So median divides the area under the curve into halves. So if the median is m, then so means that if there's a function from a and b, so let's say we call the graph here, from x equal to a until x equal to b. So then the median is then where integral from negative infinity, from negative infinity until a and m equal to integral from m to b and to positive infinity. Okay, so integral of negative infinity until m fx dx equal to 0.5, or integral from m to positive infinity of fx dx equal to 0.5. So we call integral of this will give you a function of capital letter of m with a variable of m equal to 0.5. Okay, so for continuous random variable, we are dealing with two. We call two things. First is integration, and the second thing is differentiation. Okay, example 1. Show that the function is probability density function of random variable x. Find the probability of x less than 2 and sketch the graph and state the mode. Okay. So class, first of all, the given function there, which is fx equal to 1 over 4 minus x, for x that lies in between 1 until 3. So just imagine that if we sketch a number line here from 1 until 3, okay, so this is the domain of this function from 1 until 3, okay. But then, do we have a domain from negative infinity until 1, and 3 to positive infinity? Okay, so in this domain from negative infinity until 1 and 3 to positive infinity, where the function is equal to 0. There's no function in this domain. Okay, there's only a function in this domain from x equal to 1 until x equal to 3. So then, integral of the function 1 over 4 minus x dx from x equal to 1 until x equal to 3. So 1 over 4 is a constant, take it outside. So 1 until 3, 4 minus x dx. So then 1 over 4. Integral this 1 by 1. Integral 4 respect to the x. It gives you 4x minus integral of x respect to the x. Yes, x squared over 2. Okay, so now 1 over 4. So it's time for us now to substitute the value of x with the first value, which is equal to 3 first. So then 4 times 3 minus 3 squared divided by 2 minus, okay, now it's time for us to substitute the second value of x, which is x equal to 1. 4 times 1 minus 1 squared divided by 2. 1 over 4. Okay, 4 times 3 equal to 12. 3 squared equal to 9. So then 12 minus 9 over 2 minus, okay, 4 times 1 equal to 4 and 1 squared equal to 1. So negative times 4 minus 4, negative times negative, positive 1 over 2. So now 12 minus 4. 12 minus 4 equal to 8. Negative 9 over 2 plus 1 over 2 is negative 8 over 2. Okay, so now 1 over 4. 8 minus negative, okay, 8 over 2 equal to 4. So 8 minus 4 equal to 4. Then 1 over 4 times 4 equal to 1. There you go. So now, guys, girls, with this answer here, okay, we write a conclusion says that, okay, fx is greater than 0 for x in between 1 until 3, and integral of fx dx from x equal to 1 until x equal to 3 equal to 1, we have proved just now, then this is probability, okay, probability density function of x. Okay, there you go. Okay, next, okay, for question B, we need to find the recall probability of x less than 2. Okay, just now we have sketch using the number line where the function of fx is from x equal to 1 until x equal to 3. The function of 1 over 4 times 4 minus x. And then the rest of this from negative infinity until 1 and 3 to positive infinity is all 0 and 0. So just imagine for this one here now, since there is all 0 here until 1 and 1 to, okay, from 1 up to 3, there are 2 here. So then we are talking about integral of the same function of 1 over 4 minus x dx from x equal to 1 until x equal to 2. Just now, the first solution, we are talking about integral of the whole function from negative infinity until 1. Negative infinity until 1. There's no function. There's 0 dx plus 1 up to 3, 1 over 4, 4 minus x dx plus, okay, from 3 to positive infinity, 3 to positive infinity. Do we have any function here? No, it's just a 0. So 0 dx. So this give you 0, and this one will give you 0, and the whole of this we have proved just now, which is equal to 1. Now, we just take half of this, okay, from 1 until 2, according to this, x less than 2. Okay, x less than 2, including here, but then there's no function exists. So we're talking about one, okay, integral of function from 1 until 2 only. Again, 1 over 4, 4x minus x squared over 2 from 1 until 2. Okay, so substitute x with 2 first. Okay, 1 over 4, substitute x with 2, 4 times 2 equal to 8 minus 2 squared equal to 4. 4 divided by 2 equal to 2 minus, so we substitute x with 1 now. 4 times 1 equal to 4, and 1 squared is 1 over 2. Okay, so 1 over 4. 8 minus 2 equal to 6. Negative times 4 minus 4. Negative times negative, positive 1 over 2. So then 6 minus 4 equal to 2. 2 plus 1 over 2, okay, is 3 over 2. Okay, wait a minute. 2 plus 1 over 2. So 2 times 2 equal to 4 plus 1 should be 5 over 2. Sorry. So then it is now 5 over 8. Okay, so now if I sketch that, the graph with x and also y or fx, so we have 1 over 4 here, 2 over 4, and 3 over 4. Okay, so then from x equal to 1, 2, and 3. So now we're going to plot this graph, okay, sketch this graph first. Then the function is fx equal to 1 over 4, 4 minus x. So we begin with x, okay, because it's a domain for x equal to 1 until x equal to 3. So let x equal to 1. Then f1 equal to 4 minus 1 equal to 3. 3 times 1 over 4 is 3 over 4. When x equal to 3, okay, I don't think that I need to record, take the value one by one. Just take the first, beginning, and the end, because this is linear function. Linear straight line. So then we just take two coordinates, and I chose x equal to 1 and x equal to 3. So then f3 equal to 4 minus 3 equal to 1. 1 times 1 over 4 is 1 over 4. Okay, so when x equal to 1, y equal to 3 over 4, And when x equal to 3, y equal to 1 over 4. So then sketch it. So this is it. Okay, and the mode with highest frequency, which is n when x equal to 1 and fx equal to 3 over 4. Okay. A continuous random variable x has probability density function of given that fx equal to k times x cubed, okay, where for the domain of x from 0 until 4. So class, this is the domain from 0 until 4. Then from 0 until 4, this is the domain of this function of kx cubed, and the rest of this from negative infinity until 0, and from 4 to positive infinity, then the function is 0 and 0. Okay, so find the value of k. To find the value of k, actually, that if we write this one by one from one domain to another domain here, negative infinity to 0, from negative infinity to 0, fx, which is 0 dx, plus from 0 until 4, kx cubed dx, plus with 4 to positive infinity, then the function is 0 until 4 to positive infinity, and the function is 0 dx. So this is 0, and this is also 0. And if this is a continuous random variable, okay, it's a probability function. For this case, this one, the answers of this integration here, it should give you, it's going to give you 1, equal to 1. Okay, so we're going to try now. Okay, since that given here is kx cubed, we need to find the value of k. So then, integral of kx cubed dx from 0 until 4. It must equal to 1. Okay, because in general, integral from negative to positive infinity of the function fx dx equal to 1. But then this already is 0, and this also equal to 0. So this one, only one, that will give you the answers which equal to 1. Okay, so now take a k outside. It's just a constant. Take a k outside. So then k and integral of x cubed respect to the x, it gives you x power 4 divided by 4 from 0 until 4 equal to 1. Okay, k, substitute x with 4. 4 power of 4. 4 squared is 16, 64, and 64 times 4. 64 times 4, it should be, wait a minute, 4. 4 times 4 is 16. 16 times 4, 64. 64 times 4, 16, 256. Okay, the first is 256 divided by 4 minus, substitute x with 0. 0 over 4, which is 0, equal to 1. So 256 divided by 4 equal to 64. Okay, so then k times 64 equal to 1. Then k is 1 over 64. So we call the complete function of this, which is fx equal to 1 over 64 x cubed, okay, for x lies in between 0 until 4. Okay, so it is k equal to 1 over 64, and rewrite this function in proper, then you get fx equal to 1 over 64 times x cubed. Okay, now for second question, okay, The question here, and find the value of k. We already found it. Okay, we already found it. K equal to 1 over 64. And then probability of x in between 1 until 3 and x greater than 2. So, probability of x. Which one then? Probability of x greater than or equal to 1 until 3. Okay. Just now we already agree that the integral from 0 until 4, k, which is 1 over 64 x cubed dx, it will give you equal to 1. So from the number line, it is 0 until 4. And now we try to find the value of integral of this from x equal to 1 until x equal to 3. So in between here, x equal to 1 until x equal to 3. So x equal to 1 until x equal to 3 is inside this domain of 0 until 4. So we are actually dealing with the same function of this. So from 1 until 3, 1 over 64 x cubed dx. Again, I take out 1 over 64 outside. It's just a constant here. 1 over until 3 x cubed dx. So 1 over 64. Integral of x cubed, x over 4 power 4 divided by 4 from 1 until 3. Okay, so then 1 over 64 substitute x with 3 here. So 3 power 4, 3. Okay, 3 squared equal to 9, 27, and 81. 81 over 4 minus, substitute x with 1 here, it is 1 over 4. Okay, 1 over 64. 81 minus 1, 80 over 4. 80 divided by 4, which is 20. So 20 over 64. 20 over 64 equal to 5 over 16. Am I right? 5 times 4 equal to 6. 5 times 4 equal to 20. And 16 times 4 equal to 64. Okay, that's it. And then, second question, probability of x greater than 2. So it's an integral from, okay, integral x greater than 2 here from 2 to 4 and to positive infinity across this domain. But then because in this domain from 4 to positive infinity, the function is equal to 0. So we are talking about 2 until 4 only. So from 2 until 4, 1 over 64 x cubed dx. Okay, again, class. For x greater than 2. X greater than 2 means that from 2 to 4 and cross the line 4 to positive infinity. But we agreed just now earlier that in this domain from 4 to positive infinity, the function is equal to 0. So we don't have to find it because it's meaningless. It's already called is equal to 0 then. So we are now just looking at the domain from 2 until 4 only. Okay, so 1 over 64, and because integral of x cubed respect to the x over 4 divided by 4 from 2 until 4 here. So substitute x with 4. So 4 squared equal to 16, 64, and 256. Okay, 256 divided by 4 minus, substitute x with 2. 2 squared equal to 4. 4 squared times 2 equal to 8. And 8 times 2 equal to 16 over 4. Okay, now 1 over 64. 256 divided by 4, which is 64. And 16 divided by 4 equal to 4. 64 minus 4 equal to 60. Okay, 64 minus 4 equal to 60. So then we have 60 over 64. And this one, simplify this as a 15 over 16. There you go. Okay, next question. A continuous random variable x has a probability density function of this. Sketch the final value of constant k and sketch the graph of probability and give all that here. So class, look at this. From x from 0 until 2, 2 until 3, and otherwise. Otherwise means that, okay, we have from 0 until 2. This is a domain of the function kx plus 1. And then 2 up to 3. Okay. And this is the domain for the function of 2k. So 0 otherwise means that from negative infinity until 0, the function is 0. And from 3 to positive infinity, the function is also equal to 0. So the overall of this negative infinity to positive infinity of the function fx dx, okay, means that from here, negative infinity until 0, negative infinity until 0, 0 dx, plus with 0 until 2, up to 2, 0 up to 2, kx plus 1 dx, plus 2 to 3, 2 to 3, 2k dx, plus integral from 3 to positive infinity. Then the function is 0 dx. The total is equal to 1. Okay? But then because these two automatically will give you 0. So we only count on these two functions and make sure that this integral of this plus integral of this will give you equal to 1. Okay? So now, the first question then, integral of k x plus 1 dx from 0 until 2 plus integral from 2 until 3 2k respect to the x is equal to 1. Okay, so then take a k outside, k, and integral of x plus 1. If I take the k outside earlier here, okay, so then integral of x, x squared over 2 plus 1, okay, 1 integral of 1 is x from 0 until 2. Okay, take 2k is still a constant, just like k here, take it outside. So 2k integral of 1, okay, if I take the 2k outside, there's only 1 left here. Integral of 1 respect to the x, it gives you x from 2 until 3, which is equal to 1. Okay, so now substitute the first value of x, which is 2, 2 squared equal to 4, divide by 2 equal to 2, and x equal to 2, minus, and x with 0 and 0, you know, it will be 0 here, plus with 2k, x, which x equal to 3 first, minus x equal to 2 equal to 1. Okay, so 0 here, 2 plus 2 equal to 4. So 4 minus 0 equal to 4 times k is 4k. 3 minus 2 equal to 1. 1 times 2k is 2k equal to 1. Then 4 plus 2 equal to 6k. Then k is 1 over 6. Okay, so if we rewrite the function, then fx equal to integral of 1 over 6 k, okay, x plus 1, okay, and then 2 times 1 over 6, or actually we can just write down as 2 over 6 or 1 over 3. This is for x in between 0 until 2, and here is for x equal to 2 until 3, and 0 otherwise. There you go. Okay, so find the value of k, sketch the graph of probability density function. Okay, so this is it now. this is the whole function, the proper function with, okay. Okay, so 2 times 1 over 6 is a 1 over 3, is a constant here now. So then, just imagine that, okay, this is a axis for x and y, or fx. Okay, so we have 0, 1, 2, and 3. Okay, and then the first one then, okay, from 0 until 2 and 2 up to 3. So both of these are linear. So then the first one, let's say when x equal to 0, when x equal to 0, 0 plus 1 equal to 1 times 1 over 6, then f0 is 1 over 6. And then when x equal to 2, okay, from 0 until 2, then f2 equal to, okay, x equal to 2, 2 plus 1 equal to 3. So 3 over 6, or 1 over 2. So then, let's say this is 1 over 6, 2 over 6, and 3 over 6. So when x equal to 0, it is 1 over 6. And when x equal to 2, and the value is 1 over 2, or 3 over 6. Sorry. Okay, when x equal to 2, it is 3 over 6 here. Okay, 3 over 6, then sketch the graph. It's a linear or straight line. And then, from x equal to 2 until x equal to 3, the function of fx is a constant, 1 over 3. So then 1 over 3 is 2 over 6. 2 over 6, simplify this as a 1 over 3. So from here until here, okay, it's a straight line, horizontal line right here. So this is solution for question B. Sketch the graph of probability density function. Then next, find Px 1.5 until 2.5. Okay, the graph just now, fx equal to, okay, so it is 1 over 6. Okay, x plus 1 for x in between 0 until 2, and then it is 2 over 6, or 1 over 3 for x from 2 until 3. Okay, and then zero otherwise. Okay, so now judging that these are number line from 0 until 2 and 2 until 3. So 1 over 6 x plus 1, and here is for 1 over 3. So 1.5 until 2.5, which I think that, okay, 1.5 is somewhere around here. 0 until 1 until 2. So 1.5 somewhere around here until 2.5 somewhere around here. Meaning that it crosses the border of this function and this domain of this function and the domain of this function. Meaning we are going to, okay, for the domain of 1.5 until 2, and this is the function. From 2 until 2.5, this is the function. So then, integral of 1.5 until 2, the function is 1 over 6 x plus 1 dx, plus 2 until 2.5 here, and the function is 1 over 3 dx. Okay, So then it is 1 over 6. Okay, so we have x squared over 2 plus with an x from 1.5 until 2 plus 1 over 3. Take it outside, so only 1 left here. So integral of 1 respect to the x, you come up with an x from 2 until 2.5. Okay, so now it is 1 over 6, substitute x with 2, 2 squared equal to 4, divided by 2 equal to 2, and x equal to 2. Minus, okay, 1.5 squared, 1.5 squared, which is 1.125, and, okay, 1.5 squared divided by 2, and plus with x equal to 1.5. And another one here, 1 over 3 and x, which is 2.5 first, minus with x equal to 2. So now, okay, so for this case, you just recall you may use the calculator to get the answer, and you should be, recall, they should get the answers in 0.396. Okay, next question then. Find the probability of x greater than 1.8. X greater than 1.8. Okay, again, I sketch this from 0 until 2 and 2 to 3. Okay, for this one here now is 1 over 6 x plus 1, and another one here, which is 1 over 3. Okay, x greater than 1.8. 1.8 is somewhere around here between 0 until 2, 1.8. So we are going to find the integral of this from 1.8 until 2 plus with integral from 2 until 3 and integral of 3 to infinity, which is we call the function is 0. So ignore this. We just look at this one here now. Okay, if we integrate this and this, we will get the answer. But then class, rather than, okay, beside we integrate these two functions here with these two domain here and here, why don't we just integrate from negative infinity until 0 is a 0 here, and from 0 until 1.8, but then we come up with 1 minus probability of x less than or equal to 1.8. So 1 minus of this, we only consider this from integral from 0 until 1.8. Easier, right? Okay, so now 1 minus integral from 0 until 1.8, it is 1 over 6, 1 over 6 times x plus 1, respect to the x, okay, then, okay, I make down here 1 minus, okay, 1 over 6 is a constant, take it outside, and, okay, take it outside here, 1 over 6. So integral of x plus 1 respect to the x, it's going to give you x squared over 2 plus with an x from 0 until 1.8. Okay, you may use a calculator, and for this part, okay, for this part, you should get 1 over 6, 1.62 plus 1.8, okay, and whole function, the solution of this equal to 0.43. Okay, class, I'll make a short solution for this one. In examination, please, you need to show the solution, we call substitution of this value of x into this x is x minus 0 and 0. Okay, so there's a step in between this and this one, and I do strongly suggest to you, all of you, please write it one by one. Okay. Then for question D, I rewrite the function because every pages we need to refer to we call the function of fx then. Okay, so again, the function of this just now, which is 1 over 6 x plus 1 for x in between 0 until 2, and then 1 over 3 for x in between 2 until 3, and 0 otherwise. Okay. Okay, so now from 0 until 2 and 3, this is the domain of the function of 1 over 6 x plus 1, and this is a domain of 1 over 3. Okay, you might think that the domain, if they say from this picture, from 0 until 3, you might think that the domain is between, okay, in the middle of between 0 until 3, which is 1.5. Okay, not all the time. And that's not how we find the median of this by 0 plus 3 equal to 3 divided by 2 is 1.5. No, please. Okay, so in this case, we are going to try, as we know that the median is equal to 0.5, which is from, okay, integral, let's say, okay, from negative infinity until 0 is 0, meaningless. 3 to positive infinity is also, the function is 0, so meaningless. So we begin with 0 until, okay, 0 until 2. The function of 1 over 6 x plus 1 dx. Okay, let's try. What's the result of this? 1 over 6 x squared over 2 plus with x from 0 until 2. Okay, 1 over 6, substitute x with 2. 2 squared equal to 4. Divide by 2 equal to 2. And x equal to 2 here. Minus x equal to 0 and 0, 0. So 2 plus 2 equal to 4. 4 times 1 over 6 is 4 over 6 or 2 over 3. So look at this one here. 2 over 3 is 0.66 something. Okay, 0.666 dot dot dot. Okay. And 0.66, is that less than or greater than 0.5? Yes. Which is 0.667 is greater than 0.5. Meaning, meaning the domain is somewhere around here from 0 and less than 2. Okay, so in this case, we are going to find out, we call integral from 0 until m of the function fx dx equal to 0.5. So from 0 until somewhere around here, that this one will give you the domain, we call the median is 0.5. So integral from 0 until m. So what is our value of m here? We're going to find out now. Okay, from 0 until m, and the function involved here, which is 1 over 6 x plus 1 dx equal to 0.5. Okay. 1 over 6 x squared over 2 integral of x, and then integrate 1 respect to the x plus with an x from 0 until m equal to 0.5. Okay, now 1 over 6, substitute m squared over 2 plus with an m minus x equal to 0 and 0 equal to 0.5. Okay, so now m squared over 2 multiplied with 1 over 6. So m squared over 6 times 2 equal to 12 plus with 1 over 6 m equal to 0.5. Okay, for this one, simplify this and you will get it is m squared plus 2m minus 6 equal to 0. Okay. Just imagine that, okay, 0.5 is 1 over 2. So let's say if I multiply here with 12, multiply this with 12, and multiply this also with 12. So 12 divided by 12 equal to 1. 12 divided by 6 equal to 2. And 12 times half equal to 6. So m squared, okay, m squared, then 12 divided by 6 equal to 2. Actually, it's 2 here. So 2m and 6, bring it here, bring to the side, become negative 6. So we get quadratic here, m squared plus 2m minus 6 equal to 0. Okay, m squared plus 2m minus 6 equal to 0. Factorize this if possible. M and m. So 6. 6, we look at that multiplication of 1 multiplied with 6 and 2 multiplied with 3. Okay, so class, the difference 1 minus 6 equal to negative 5 or 1 plus 6 equal to 7. We cannot get 2 here. And also 2 with 3. 2 plus 3 equal to 6. So 2 minus 3 equal to negative 1. We will not get 2 here. So in this case, you need to use the formula. Okay, the formula of what we call to find an x, which is negative b plus minus square root of b squared minus 4 minus 4ac divided by 2a. Do you still remember this? Okay, use this to find the value of x. You will get, okay, we cannot simply use the integral we call the factorization. You use the formula here. So then m1 equal to 1.65 or m2 equal to negative 3.65. Okay, the thing here now is, okay, m, if this is the value of m, 1.65, and another one is negative 3.65, which one of this value that reasonable for us to we call the put here as the value of m between 0 until 2? Yes, 1.65. So it means that here the value of m here now is 1.65. There you go. Okay, so guys, girls, that's all for today. Thank you for watching my videos, and hopefully that these videos help you in your completing your lecture notes and your study, your revision. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.